Get started. This page walks you through setting up a P5.js project and making your first sketch. The easiest way to start is using the P5.js editor. You can open the web editor and can scroll down to your first sketch. If you would like to work on the desktop version of P5.js, you can scroll down to downloading instructions. Your first sketch. In the P5.js web editor, you should find the following code. Function setup, create canvas, 400, function draw, background, 220. Copy. After background, 220, include this line of code, ellipse, 50, 50, 80, 80. Now your code should be like this. Function setup, create canvas, 400, function draw, background, 220, ellipse, 50, 50, 80, 80. Copy. The line you just added draws an ellipse, with its center 50 pixels over from the left and 50 pixels down from the top, with a width and height of 80 pixels. On the editor, press play to display your code in action. If you are using a screen reader, you must turn on the accessible outputs in the P5 online editor. Outside the editor, you must add the accessibility library in your HTML. To learn more, visit using P5 with a screen reader tutorial. If you've typed everything correctly, this will appear in the display window. If nothing appears, the editor may be having trouble understanding what you've typed. If this happens, make sure that you've copied the example code exactly. The numbers should be contained within parentheses and have commas between each of them. The line should end with a semicolon. An ellipse has to be spelled correctly. One of the most difficult things about getting started with programming is that you have to be very specific about the syntax. The browser isn't always smart enough to know what you mean, and can be quite fussy about the placement of punctuation. You'll get used to it with a little practice. In the bottom left of the editor, you will find the console section. Here, you can find messages from the editor with details about any errors it encounters. Next, we'll skip ahead to a sketch that's a little more exciting. Modify the last example to try this. Function setup, create canvas, 400, function draw, if, mouse is pressed, fill, 0, else, fill, 255, ellipse, mouse X, mousey, 80, 80. Copy. This program creates a canvas that is 400 pixels wide and 400 pixels high, and then starts drawing white circles at the position of the mouse. When a mouse button is pressed, the circle color changes to black. Run the code, move the mouse, and click to experience it. What next? Check out the Learn page and Examples page for more. Watch the Coding Train and Cadence video tutorials. View the reference for full documentation. If you wish to use P5 with a screen reader, check out the P5 with a screen reader tutorial. If you have used processing in the past, read the processing transition tutorial to learn how to convert from processing to P5.js and the main differences between them. Setting up P5.js with an editor on your own computer. To run P5.js in your computer, you will need a text editor. You can use the code editor of your choice. Instructions for getting set up with Sublime Text 2 are included below. Other good editor options include brackets and Atom. If you are a screen reader user and not using the P5 web editor, you may want to use Notepad++ or Eclipse. Downloading a copy of the P5.js library. The easiest way to start is by using the empty example that comes with the P5.js complete download. After download, you need to set up a local server. See instructions here. Run your local server within the downloaded folder, and on your browser, go to http://localhost, your port number, /empty example. If you look in index.html, you'll notice that it links to the file p5.js. If you would like to use the minified version, compressed for faster page loading, change the link to p5.min.js. Script src equals /p5.min.js/script. Copy. Using a hosted version of the P5.js library. Alternatively, you can link to a P5.js file hosted online. All versions of P5.js are stored in a CDN, Content Delivery Network. You can find a history of these versions in the P5.js CDN. In this case, you can change the link to script src equals https://cdn.deliver.net/npm/p5 at 1.5.0/lib/p5.js/script. Copy. A sample HTML page might look like this. HTML head script src equals https://cdn.deliver.net/npm/p5 at 1.5.0/lib/p5.js/script src equals sketch.js/script/head body a main/main/body/html. Copy. Environment. Open Sublime. Go to the File menu and choose Open, and choose the folder that your HTML and JS files are located in. On the left sidebar, you should find the folder name at the top, with a list of the files contained in the folder directly below. Click on your sketch.js file and it will open on the right where you can edit it. Open the index.html file in your browser by double-clicking on it in your file manager or type file://the/file/path/to/your/localhost, or http://localhost, your port number, /empty example if you are using a local server, in the address bar to view your sketch. Parts of this tutorial were adapted from the book, Getting Started with P5.js, by Lauren McCarthy, Casey Rees, and Ben Fry, O'Reilly/Make 2015. Copyright 2015. All rights reserved. Last modified at the P5.js 2019 Contributors Conference. Forum. GitHub. Twitter. Instagram. Discord. P5.js is currently led by Qianshan Yi and was created by Lauren Lee McCarthy. P5.js is developed by a community of collaborators, with support from the Processing Foundation and NYU ITP. Identity and graphic design by Jarrell Johnson. Copyright info. Processing. P5.js. Processing.py. Processing for Android. Processing for Pi. Processing Foundation. Skip to main content. Learn. These tutorials provide more in-depth or step-by-step overviews of particular topics. Check out the examples page to explore short demonstrations of various P5.js topics. Introduction to P5.js. Getting started. Welcome to P5.js. This introduction covers the basics of setting up a P5.js project. P5.js overview. An overview of the main features of P5.js. P5.js and processing. The main differences between the two, and how to convert from one to the other. Using a local server. How to set up a local server on Mac OS X, Windows, or Linux. P5.js Wiki. Additional documentation and tutorials contributed by the community. P5 with a screen reader. Setting up P5 so that it can be used easily with a screen reader. Connecting P5.js. Node.js and Socket.io. Using a Node.js server with P5.js, communication via Socket.io. Programming topics. Beyond the canvas. Creating and manipulating elements on the page beyond the canvas. 3D/WebGL. Developing advanced graphics applications in P5.js using WebGL mode. Color. An introduction to digital color. Coordinate system and shapes. Drawing simple shapes and using the coordinate system. Curves. An introduction to the three types of curves in P5.js, arcs, spline curves, and Bezier curves. Interactivity. Introduction to interactivity with the mouse and keyboard. Program flow. Introduction to controlling program flow in P5.js. Becoming a better programmer. Debugging. Field guide to debugging for everyone. Optimizing P5.js code for performance. A tutorial of tips and tricks for optimizing your code to make it run faster and smoother. Unit testing and test-driven development. Save yourself from agony on install day. What is unit testing and how to use it? By Andy Timmons. Contributing to the community. Development. Getting started and overview for contributing to development. Looking inside P5. A friendly intro to the file structure and tools for P5.js development by Luisa Pereira. Writing a tutorial. A guide to writing a P5.js programming tutorial. Creating libraries. Creating P5.js add-in libraries. Forum. GitHub. Twitter. Instagram. Discord. P5.js is currently led by Chan Yi and was created by Lauren Lee McCarthy. P5.js is developed by a community of collaborators, with support from the Processing Foundation and NYU ITP. Identity and graphic design by Jarrell Johnson. Copyright info. Processing. P5. P5.js overview. Kenneth Lim edited this page December 15, 2021, 31 revisions. Pages 27. Home. Archived content. Beyond the canvas. Drawing text using web fonts. Educational resources. Embedding P5.js. Getting started with WebGL in P5. Global and instance mode. Google Season of Docs. Google Season of Docs apply by email instructions. How to load custom fonts to P5.js web editor. JavaScript basics. Loading external files, AJAX, XML, JSON. Local server. Modo's global e-instance. Show 12 more pages. Clone this wiki locally. P5.js is a JavaScript library that starts with the original goal of processing, to make coding accessible for artists, designers, educators, and beginners, and reinterprets this for today's web. Using the original metaphor of a software sketchbook, P5.js has a full set of drawing functionality. However, you're not limited to your drawing canvas, you can think of your whole browser page as your sketch. For this, P5.js has add-in libraries that make it easy to interact with other HTML5 objects, including text, input, video, webcam, and sound. P5.js is a new interpretation, not an emulation report, and it is in active development. You can also read how this differs from processing.js, or about how this relates to processing. Hello world. Please see the Get Started page for instructions for setting up your editing environment and project. There are two main functions you will use in your program. The setup block runs once, and is typically used for initialization, or for creating a program that does not need a loop running code repeatedly. The draw block runs repeatedly, and is used for animation. For your first Hello World program, create a setup block and add one line. Function setup, line, 15, 25, 70, 90. If you view this in your browser, you should see a single line. Adding a draw block enables you to incorporate animation. In the example below, a variable is updated every time draw runs, moving a circle across the screen. Let x equals 0, function setup, background, 100, function draw, ellipse, x, height /2, 20, 20, x equals x plus 1. There is a full set of 2D drawing methods to create and styles graphics, text, and images. See the reference for the full listing and the examples page. To load P5 onto the page, either setup or draw is required, but not both, or you may use instance mode to have more control over when and how your sketch gets loaded. Create canvas. By default, the drawing canvas has a size of 100 by 100. If you want to set a custom size, use the Create Canvas function. It is a good idea to always make this the first line in setup. The code below sets the canvas to size 600 by 400. Function setup, create canvas, 600, 400, line, 15, 25, 70, 90. Create canvas will create a new drawing canvas in the size specified and append it to the HTML page you are working with. If there is other content in the body of your HTML page, it will add on to the page after that, so you may not see it at the top of the window. The canvas will also be affected by any existing CSS styling on the page, including default set by your browser. For example, a lot of browsers have a default padding around the end of the page. If you are noticing that your canvas isn't all the way at the upper left corner of your window, this is probably why. To fix this, you can add a line to the head of your HTML file that overrides the default padding, like this. Style body, padding 0, margin 0, /style. If you would like to specify a location for the canvas, rather than appending directly to the end, you can use the parent method. In the body of your HTML file, create a container where you would like your canvas to get inserted, with ID of your choice. div ID equals mycontainer/div. Then use a variable to store a pointer to the canvas you created, and call .parent on this variable. Function setup, let myCanvas equals create canvas, 600, 400, myCanvas.parent, myContainer. The P5.js API provides a lot of functionality for creating graphics, but there is some native HTML5 canvas functionality that is not exposed by P5. You can still call it directly using the variable drawing context, as in the example below. See this reference for the native Canvas API. Function setup, drawing context.shadow_offset x equals 5, drawing context.shadow_offset y equals -5, drawing context.shadow_blur equals 10, drawing context.shadow_color equals black, background, 200, ellipse, width/2, height/2, 50, 50. Mouse and touch interaction. P5.js has a set of methods for handling mouse and touch interaction. The list below shows how they relate conceptually. Mouse. Touch. Touches. Mouse is pressed. Mouse pressed. Touch started. Mouse moved. Mouse dragged. Touch moved. Mouse released. Touch ended. Mouse clicked. Mouse scrolled. You may notice with touch, unless you have defined a touch started method, the screen may react with default touch behavior for your mobile device, i.e. your whole screen view may move around when you drag your finger. If you add an empty touch started method, you should see this stop. Many browsers have default behaviors for various interactions. For example, touch moved on a mobile device may result in dragging the whole window. To prevent these behaviors, add a return false line at the end of your defined functions. Function touch moved, / do some stuff return false. Asynchronous calls and file loading. JS is single-threaded and synchronous, meaning one line of code completes before the next one runs. However, there are asynchronous functions used that make the program flow faster. Loading images, external files, and URLs are generally handled by async functions. Note, loading files from the sketch folder will require that you are running a local server. See here for a tutorial about how to set one up on your computer. Callbacks. All of the load functions will accept a callback function as an optional last argument. In the following example, an image is drawn once it is loaded. Function setup, create canvas, 400, 240, load image, cat.jpg, draw cat, function draw cat, img, image, img, 0, 0. Compare this to calling image, directly after load image, which ends up blank. Function setup, create canvas, 400, 240, let img equals load image, cat.jpg, image, img, 0, 0. Preload. Alternatively, you could use the preload function. If a preload block exists, it runs first, then setup will wait until everything in there has completed before it gets run, so you can make use of things loaded in preload in setup and draw. Note that nothing else should be in preload besides load calls, all other initialization should happen in setup. No callbacks are required for load functions in preload. Let img, function preload, img equals load image, cat.jpg, function setup, create canvas, 400, 240, image, img, 0, 0. Loading screen. As mentioned above, if your sketch has large media dependencies such as images, audio or videos, these should be loaded into your sketch using the preload function. Since loading large files can take some time, you might want to display a loading screen to your users. This will convey that your sketch is indeed running, it just has a lot of cool things to load first. To add a loading screen to your P5.js sketch, all you need to do is include an HTML element on your page with the ID P5_loading. It would look something like the following. div ID equals P5_loading, class equals loading class. This could be some sweet graphics loading lots of bits /div. P5.js looks through your HTML to see if you have included an element with the ID P5_loading. P5.js will use this element and its content as the loading screen for your sketch. Since the loading element is included in your HTML, you can add any additional classes and/or style the element any way you see fit. For an example of a sketch using a loading screen, refer to examples /loading screen/index.html in the P5.js source. Browser functions and native JavaScript. There are a few variables and functions that make browser interaction easier, many more to come. Window width/window height. Display width/display height. WinMouse X/WinMouse Y. Full screen. You should also be able to use any native JS functions in your P5.js sketch without a problem. The MDN JavaScript reference is a good place to learn more. Read the next section to learn how to make P5 play extra nice with the rest of your project. Instantiation/namespace. By default, all P5.js functions are in the global namespace, i.e. bound to the window object, meaning you can call them simply ellipse, fill, etc. However, this might be inconvenient if you are mixing with other JS libraries, synchronously or asynchronously, or writing long programs of your own. P5.js currently supports two ways around this problem: instance mode and on-demand global mode. In instance mode, all P5 functions are bound up in a single variable instead of polluting your global namespace. Consider a program like this. Let x equals 100, let y equals 100, function setup, create canvas, 200,200, function draw, background, 0, fill, 255, ellipse, x, y, 50, 50. A conversion to instance mode looks like this. Const s equals, p, equals, let x equals 100, let y equals 100, p.setup equals function, p.create canvas, 700, for 10, p.draw equals function, p.background, 0, p.fill, 255, p.rect, x, y, 50, 50, let myp5 equals new p5, yes. Optionally, you can specify a default container for the canvas and any other elements to append to with a second argument. You can give the ID of an element in your HTML or an HTML node itself. Let myp5 equals new p5, s, my container. Note that creating instances like this also allows you to have more than one P5 sketch on a single web page, as they will each be wrapped up with their own setup variables. Of course, you could use iframes to have multiple sketches in global mode. Another option is on-demand global mode. To initialize on-demand global mode at any point in a web page's lifetime, simply call new P5, without any arguments. Calling P5 explicitly this way gives you more control over how your sketch is loaded, which is helpful when you're working with other libraries. Along these lines, on-demand global mode also allows P5 to be instantiated before page load, so folks who really want to work around the assigning variables using P5 functions and variables before setup limitation can write the following sorts of sketches. New P5, let boop equals random, 100, function setup, create canvas, 100, 100, function draw, background, 255, 0, boop. Libraries. One of the core ideas behind P5.js is that your sketch is not just the graphics canvas but the whole web page in your browser. For this reason, there is the P5.dom library that makes it easy to interact with other HTML5 objects, including text, hyperlink, image, input, video, audio, and webcam. There is also a P5.sound library that provides a friendly interface to HTML5 Web Audio API for loading, playing, and synthesizing sounds. Learn how to use these libraries or develop your own here. Editor. You can use any editing environment you like. In addition, the P5.js web editor has been officially launched. You can try that out too. The P5.js web editor handles setting up projects and the server is set up internally for you. You can usually run P5.js sketches without a server, but it is required if you are doing certain things like loading external files. Here are the instructions for setting up a local server. FAQ. How is this different than processing.js? The main goal of processing.js is to execute processing files in HTML5, but not necessarily to write native HTML5. It supports a mixed syntax of processing and JavaScript, where the JavaScript is not really meant to be consumed by the end user. Processing.js is a port of processing to JS, using regex to convert Java into JS. It is a good tool for those that want to run simple sketches on the web, however, it is quite opaque. It can be difficult for someone to understand how it works, how to fix things when it doesn't work, or how to modify or extend the library. As processing.js says on their website, it's not magic, but almost. In contrast, with P5 we are reimagining processing's original goals in native JavaScript, in a way that is intended to be transparent and intuitive. It is easy to translate a sketch from processing to P5 and the process of doing so begins to teach people the basics of JS. From there, they are able to begin writing native JS using a syntax that feels familiar but appropriate for the context. We are closely studying the decisions processing has made, but also always questioning to see if there are design decisions that would make the library cleaner, stronger, and more intuitive. Additionally, P5.js extends beyond canvas drawing to allow people to create, access and manipulate other HTML elements. Through this framework, beginners begin to explore and understand HTML, JavaScript, and CSS, and the way they work together in the browser. P5.js will also have a system for people to contribute add-on modules to deal with things like audio, video, various input devices, and data. There is also an option to use P5 globally or instantiated within a namespace, so it can be compatible with other JS libraries. Most importantly, this project is in active development, with enthusiastic support and contributions from around the world. We have begun working with various schools and institutions to teach workshops and classes, in hopes of integrating it into curricula as a tool for understanding the web. We are also putting a lot of energy into making the documentation clear, for developers as well as users. We'd like this to be a project that anyone feels welcome and empowered to be a part of, whether that's contributing documentation, writing code, teaching with it, or using it to create. How did this project originate? This project developed out of a fellowship with the Processing Foundation exploring the future of processing with JavaScript. Documentation of research in process and references is here. Do all the variables have to be in the global namespace? Can I run multiple sketches on one page? By default, all P5.js functions are in the global namespace, i.e. bound to the window object, meaning you can call them simply ellipse, fill, etc. However, this might be inconvenient if you are mixing with other JS libraries or writing long programs of your own. To solve this problem, there is something we call instance mode, where all P5 functions are bound up in a single variable instead of polluting your global namespace. See more info here. Why can't I assign variables using P5 functions and variables before setup? Well, technically, you can by using on-demand global mode. But that's a less common use of P5, so we'll explain that later and talk about the more common case first. In regular global mode, P5 variable and function names are not available outside setup, draw, mouse pressed, etc., except in the case where they are placed inside functions that are called by one of these methods. What this means is that when declaring variables before setup, you will need to assign them values inside setup, if you wish to use P5 functions. For example, let n, function setup, create canvas, 100, 100, n equals random, 100. The explanation for this is a little complicated, but it has to do with the way the library is set up in order to support both global and instance mode. To understand what's happening, let's first look at the order things happen when a page with P5 is loaded, in global mode. Scripts in head are loaded. Body of HTML page loads. When this is complete, the onload event fires, which then triggers step 3. P5 is started, all functions are added to the global namespace. So the issue is that the scripts are loaded and evaluated before P5 is started, when it's not yet aware of the P5 variables. If we try to call them here, they will cause an error. However, when we use P5 function calls inside setup and draw, this is okay, because the browser doesn't look inside functions when the scripts are first loaded. This is because the setup and draw functions are not called in the user code, they are only defined, so the stuff inside of them isn't run or evaluated yet. It's not until P5 is started up that the setup function is actually run, P5 calls it for you, and at this point, the P5 functions exist in the global namespace. We mentioned on-demand global mode earlier. This mode is most useful when you're building a program that uses other libraries and you want to control how P5 is loaded on the page with the others. You can read more about it here. But another interesting use of on-demand global mode is the ability to call P5 explicitly and then use P5 functions outside of setup. Here's an example. New P5, var boop equals random, 100, function setup, create canvas, 100, 100, function draw, background, 255, 0, boop. You may get a warning saying that P5.js has been imported twice, but things should still work as expected. https://p5js.org. If you would like to edit this wiki and don't already have edit access, please open an issue or comment on an existing one noting the wiki page you'd like to edit. You will then be added as a repository contributor with edit access. Copyright 2023 GitHub Incorporated. Terms. Privacy. Security. Status. Processing transition. Stalgia Grig edited this page December 16, 2019, 48 revisions. Pages 27. Home. Archived content. Overview of differences. The P5.js language looks very similar to the processing language with a few changes. Because you can think of your sketch as more than just the drawing canvas, size has been replaced with create canvas to suggest the possibility of creating other elements. Frame rate, number, sets the frame rate, but the frame rate variable has been removed. To get the current frame rate, call frame rate, with no arguments. JavaScript doesn't always load things synchronously, so there are a couple options to deal with this. All load methods take an optional callback argument. That is, a function that gets called after the file has been loaded. Alternatively, you can place load calls in a preload method that happens before setup. If a preload method exists, setup waits until everything inside is loaded. See this image example. The variable mouse pressed has been replaced with mouse is pressed. In addition to mouse events, there are touch events. The mapping is like this. Mouse X touch X. Mouse it touchy. Mouse pressed, touch started. Mouse dragged, touch moved. Mouse released, touch ended. There is a touches array that contains a series of objects with X and Y properties corresponding to the position of each finger. Push/pop matrix and push/pop style have been replaced with push and pop, the equivalent of calling both matrix and style methods together. By default, everything is in the global namespace, and you can create your sketches like you do with processing. However, there is something we call instance mode for creating a P5 sketch that plays nice with the rest of the code running on your page. See this instance mode example and this global versus instance mode tutorial. In global mode, P5 variable and function names are not available outside setup, draw, mouse pressed, etc., except in the case where they are placed inside functions that are called by one of these methods. What this means is that when declaring variables before setup, you will need to assign them values inside setup, if you wish to use P5 functions. For example, var n, function setup, create canvas, 100, 100, n equals random, 100. The function println is not available in P5.js. Use print or console.log. The origin, 0, 0, 0, for WEBGL mode is in the center of the canvas, rather than the top left as it is in 2D mode. WebGL uses column major matrices. When translating 3D sketches that apply matrices from processing to P5, matrices can be transposed to achieve the same results. Not everything in processing is implemented in P5.js, but we are working on it. Right now there is no P-shape equivalent. The camera model in P5.js is yet very basic, with only eye position and no look at or axis direction. See the reference for up-to-date documentation of what functions work. Some things about JavaScript. Variables do not have a type. Use let or the older syntax var instead of float, int, double, long, char, string, array, etc. You do not need to specify return types or parameter types for functions. A var can be anything, any of the types mentioned, but also functions. Arrays are constructed very simply, no need for processing's array list anymore, and have many built-in features. See this array example and learn more about JS arrays here. JavaScript uses something called prototypes to form something similar to Java class objects. See this objects example and learn more about JS objects here. Conversion examples. Basic sketch. This is the basic setup for a processing in P5.js sketch. Note that P5.js will also require an empty HTML file that links to the P5.js library and your sketch file in the header. See getting started. Void setup, / setup stuff, void draw, / draw stuff. Function setup, / setup stuff, function draw, / draw stuff. Converting a processing sketch to P5.js. Here are two examples of sketches that have been converted from processing to P5.js. The changes made are shown in the comments, all the other lines remain the same. /*****. This example can be found in the processing examples package * that comes with the processing pde.v * processing examples basics formed Bezier * adapted by Evelyn Ismond * function setup / change void setup to function setup create canvas 640 360 / change size, to create canvas, stroke, 255, / stroke, is the same no fill, / no fill, is the same, function draw, / change. Asterisk void draw, to function draw, background, 0, / background, is the same for, var I equals 0, I less than 200, I plus equals 20, / change in I to var I Bezier, mouse x dash, I slash 2.0, 40 plus I, 410, 20, 440, 300, 240 dash, I slash 16.0, 300 plus, I slash 8.0, / Bezier, is the same. /***, this example can be found in the processing examples package * that comes with the processing PDE. * processing examples topics interaction follow 3 * adapted by Evelyn Isman * var x equals new array 20 / change float x equals new float 20 to new array 20 var y equals new array 20 / change float y equals new float 20 to new array 20 var seg length equals 18 / change float to var function setup / change void setup to function setup create canvas 640 360 / change size to create canvas stroke weight 9 / stroke weight is the same stroke 255 100 / stroke is the same for var I equals 0 I less than x dot length I plus plus / initialize the array x I equals 0 y I equals 0 function draw / change void draw to function draw background 0 / background is the same. Draw segment 0 mouse x mouse a / functions calls mouse x and mouse a are the same for var I equals 0 I less than x dot length 1 I plus plus / change in I to var I draw segment I plus 1 x a y I / function calls are the same function draw segment I xin eam / change void draw segment to function draw segment remove type declarations var dx equals xin x / change float to var dy equals in y I / change * float to var angle equals atten 2 dy dx / change float to var atten 2 is the same x I equals xin cos angle * seg length / cos is the same y I equals in sin angle * seg length / sin is the same segment x I y I angle / function calls are the same function segment x y a / change void segment to function segment remove type declarations push / push matrix becomes push translate x y / translate is the same rotate a / rotate is the same line 0 0 seg length 0 / line is the same pop / pop matrix becomes pop. Converting a P5.js sketch to processing. Here are 2 examples of sketches that have been converted from P5.js to processing. The changes made are shown in the comments, all the other lines remain the same. /***, this example can be found in the processing examples package * that comes with the processing PDE. * processing examples basics form Bezier * void setup / change function setup to void setup size 640 360 / change create canvas to size stroke 255 no fill void draw / change function draw to void draw background 0 for int I equals 0 I less than 200 I plus equals 20 / change var I to int I Bezier mouse x dash I slash 2.0 40 plus I 410 20 440 300 240 dash I slash 16.0 300 plus I slash 8.0 /***, this example can be found in the processing examples package * that comes with the processing PDE. * processing examples topics interaction follow 3 * based on code from Keith Peters. * float x equals new float 20 / change array of zeros to be float x equals new float 20 float y equals new float 20 / change array of zeros to be float x equals new float 20 float seg length equals 18 // change var to float void setup, // change function setup to void setup, size 640, 360, // change create canvas to size, stroke weight 9. Stroke 255, 100, void draw, // change function draw, void draw, background 0, drag segment 0, mouse x, mouse a, 4, int I equals 0, I less than x dot length 1, I plus plus, // change var I to int I drag segment, I plus 1, x, I, y, I, void. Drag segment. Int I, float xin, float in, // change function draw segment to void draw segment. Add type declarations. Float dx equals xin, x, I, // change var to float dy equals in, y, I, // change var to float angle equals addn 2, dy, dx, // change var to float x, I, equals xin, cos, angle, asterisk seg length, y, I, equals in, sin, angle, asterisk seg length, segment, x, I, y, I, angle, void segment, float x, float y, float a, // change function segment to void segment. Add type declarations. Push matrix, translate, x, y, rotate, a, line, 0, 0, seg length, 0, pop matrix. Declaring variables. In P5.js, all variables, whether they are numbers, strings, arrays, functions, objects, whatever, are declared using the symbol var, or in newer browsers, let or const. Unlike in processing, you don't have to specify the variable type. For example, instead of Boolean button equals false, you'd write var button equals false. Or instead of float x equals 100.3, you'd write var x equals 100.3. Here is a summary of the supported processing data types, table borrowed from Getting Started with Processing. Name. Description. Range of values. Int. Integers, whole numbers. -2,147,483,648 to 2,147,483,647. Float. Floating point values. -3.4028234 times 10 to the power of 38 to 3.4028234 times 10 to the power of 38. Boolean. Logical value. True or false. Char. Single character. AZ, 0 to 9, and symbols. String. Sequence of characters. Any letter, word, sentence, and so on. Pimage. PNG, JPG, or GIF image. Not applicable. P-font. VLW font, use the Create Font tool to make. Not applicable. P-shape. SVG file. Not applicable. What next? Check out the P5.js reference for up-to-date documentation. Play with the examples and demos on the tutorials page. Some functionality, loading external files, for example, works as expected when the files are placed online via FTP or SSH. However, if you try to view them locally, you see some kind of cross-origin errors in console. The solution to this is to view them using what's called a local web server. This tutorial includes instructions for setting up several types of local web servers on each of Mac OS X, Windows, and Linux. This tutorial assumes a basic understanding of the command line interface. For a quick introduction, see the command line introduction wiki. For the beginners coming from the Get Started page, if you opted for Sublime Text Editor, a very simple way to set up a local server, without having to know the command line interface, is to use the Browser Sync plugin for Sublime Text 3. Brackets Editor. If you use the free and open source Brackets Editor to write your code, a local server comes built in. With your HTML file open, select File Live Preview, or click the lightning bolt icon. Brackets will launch Chrome and open your file in a new tab. Web server for Chrome extension. The simplest and fastest solution for anyone using a Chrome web browser is to install the web server for Chrome extension. Visit its Chrome Web Store page and install it. By default, the web server won't run in the background, so keep it open for it to work. To launch it on most devices, type Chrome//apps in the Chrome address bar and press Enter to see all your Chrome apps, then click the web server icon. On a Chromebook, press the search key, magnifying glass tilted left, or click the launcher icon, usually at the bottom left corner of the screen, to find and launch the web server. After launching the web server, a new window will open. There you can click Choose Folder, and select the folder with the HTML page for your sketch. Now you can just click on the web server URL, http://127.0.0.1:8887 by default, to see and open your sketch. If you name your sketch HTML page index.html and enable automatically show index.html, your sketch will load as soon as you open the URL. VS Code Live Server. Using the Live Server extension for VS Code, we can easily run a development web server for any local folder. Instructions. Open the VS Code Extension Manager, Ctrl+Shift+X/CMD+Shift+X. Search for and install the Live Server extension. Add a P5.js project folder to your VS Code workspace. With your project's index.html or sketch.js file open, start the live server using the Go Live button in the status bar, or by using Alt+L. Your sketch should now open in your default browser at location 127.0.0.1:5500. Another handy VS Code extension is P5.js, which includes a project generator, an easy way to install contributor libraries, and adds P5.js auto-completion support. Python Simple HTTP Server. If you need a quick web server running and you don't want to mess with setting up Apache or something similar, then Python can help. Python comes with a simple built-in HTTP server. With the help of this little HTTP server, you can turn any directory in your system into your web server directory. The only thing you need to have installed is Python. Python is already installed if you are using Mac OS X. Python Simple HTTP Server Tutorial. Type in terminal. Python m Simple HTTP Server. Or if you are using Python 3, type Python m http.server. Then visit http://localhost 8000 on your browser. Unfortunately, the Python Simple server is very slow. Loading a local page will often stall, and it can't stream video and has trouble with even medium-sized files like an 8 MB MP3 for example. However, it should suffice for loading in most text files, fonts, and most images. Node HTTP Server. An alternative is Node.js HTTP Server. It is much faster than Python's Simple Server while requiring a little bit of setup. Just 3 simple steps. Download and install Node.js. Open a terminal or command prompt. On Windows you might need to open the command prompt as admin. In the terminal type npm install GHTTP server. Done. From then on, just cd to the folder that has the files you want to serve and type HTTP server. Then point your browser at http://localhost 8080/. Note 1. If you are having problems where the browser does not reload your JavaScript files after changes are made, you may need to instantiate the server with a specific cache value. To do this, include the cache timeout flag with a value of -1. This tells the browser not to cache files, like sketch.js. HTTP server C1. Alternatively, you can set up a browser sync server which has the added benefit of automatically reloading the web page when any changes were saved in the source code. Follow instructions above to install Node.js and open a terminal/command prompt window. Type npm install g browser sync. cd into your project folder. Type browser sync start server fw. Your website should be available at http://localhost 3000, and whenever you save a file in your project, the web page will automatically reload. https://www.browsersenc.io/$ install. https://github.com/codingtrain/rainbow-topics/issues/646. Note 2. if you encountered an error that says eches when installing either HTTP server or browser sync, it means npm is not installed with the right permissions. Follow the steps outlined at https://docs.npm.js.com/getting-started/fixing-npm-permissions to fix it. Using PHP built-in web server. PHP has, since version 5.4.0, a built-in web server for testing purposes that can be used to test P5.js sketches. To check if you have PHP installed, you can open a terminal and issue the command PHP version. If you have PHP CLI, command line interpreter, installed, you can start a local development server by using the command PHP s localhost 8000. Then point your browser at http://localhost 8000/. Setting up browser sync for Sublime Text, command line free option. The browser sync plugin for Sublime Text allows you to launch your project in the browser and having the page refresh each time you save a modification to your file, Ctrl+S. To install the plugin, you will first need load the package repository by doing this. Open the command palette by using Ctrl+Shift+P or going to Tools, Command Palette. Type install package and hit enter. The repository will be loaded in a matter of seconds. Once the repository is loaded, you can search and launch the installation of the browser sync plugin. Inside the same command palette, type browser sync. The suggest option shows you the browser sync plugin. Click on it and hit enter. Once completed the installation of the plugin, a new menu, browser sync, appears on the menu bar. Now that the browser sync plugin is installed on your Sublime Text editor, here is how to use it. Say you have Chrome opened and in Sublime Text your P5.js project is open too. In the Browser Sync menu, go to Start File and choose your /index.html file. Then, go to Browser Sync menu again and click Launch. Now your project should open in a new Chrome tab. Each time you'll save, Ctrl+S, your modifications in Sublime Text, your project's Chrome tab will refresh. And voila! https://p5js.org. If you would like to edit this wiki and don't already have edit access, please open an issue or comment on an existing one noting the wiki page you'd like to edit. You will then be added as a repository contributor with edit access. Copyright 2023 GitHub Incorporated. Terms: privacy, security, status, docs, contact GitHub, pricing, API, training, blog, about. Wiki. Welcome to the P5.js wiki. Cherry Blossom. We welcome everyone to participate in this wiki. If you would like to edit this wiki and don't already have edit access, please open an issue or comment on an existing one noting the wiki page you'd like to edit. You will then be added as a repository contributor with edit access. What is P5.js? P5.js is a JavaScript library for creative coding, with a focus on making coding accessible and inclusive for artists, designers, educators, beginners, and anyone else. P5.js is free and open source because we believe software, and the tools to learn it, should be accessible to everyone. Using the metaphor of a sketch, P5.js has a full set of drawing functionality. However, you're not limited to your drawing canvas. You can think of your whole browser page as your sketch, including HTML5 objects for text, input, video, webcam, and sound. Tutorial. A complete list of tutorials can be found on the P5.js Learn page. There is one page, Archived Content, that contains some of the older material that used to be in this wiki, in case you are missing it. Here are some resources for further P5.js learning. Get started, create and run your first sketch. API reference, the documentation for P5.js. Learn, tutorials introducing different P5.js topics. Examples, short, prototypical examples exploring the basics of programming with P5.js. Development. If you are interested in developing P5.js, please see the contributor_docs folder in the repository. The README in this folder contains an overview of how to contribute, build the library, test the code, and update the documentation. Here are some further resources for P5.js development. P5.js contribute page. Learn about different ways to contribute to P5.js. Community statement and code of conduct, a guide on what we value and how to best interact within the community. P5.js overview, an overview of the main features and functionality of P5.js. Development guide, how to contribute to P5.js software development. Google Summer of Code and Processing Fellowships. Wrap-up reports for projects from P5.js related Google Summer of Code projects, processing fellowships, and others. Season of Docs. P5.js has been participating in Season of Docs since 2021. Season of Docs 2022. Organization application, organize and develop P5.js contributor docs. Season of Docs 2021. Case study, new contributor onboarding and friendly error system documentation. License. P5.js is licensed under the GNU Lesser General Public License version 2.1. Using P5 with a screen reader. This page introduces some of the screen reader-friendly features of the P5.js web editor. It provides an overview of accessible outputs, and examples and tutorials on how to get started with P5 when using a screen reader. P5.js is a library that starts with the original goal of processing, to make coding accessible for artists, designers, educators, and beginners, and reinterprets it for the web using the metaphor of a software sketchbook with a set of drawing functionality. With P5.js we are able to draw in the canvas. The canvas is perhaps the most inaccessible element in HTML. The reason for this is simple. The canvas behaves just like a physical canvas. Once you put paint on it, it covers up what's behind it, making it hard to understand how the pixels comprise shapes and elements. Within the P5.js web editor it is possible to access the content of the canvas using a screen reader through text, a spatial table, and sound outputs. What is the P5.js web editor? The P5.js web editor is essentially a web page where you can type code in P5.js and run the code to view the output. It allows us to code in and for the browser. The web editor has features that make it screen reader friendly. You can access the P5 web editor here. Pairings. Please note, the P5.accessibility library is currently not supported on macOS. Using the P5.js web editor with a screen reader works better when you have one of the following screen reader/browser/operating system pairings. NVIDIA and Firefox. JAWS and Chrome. Outputs. With a screen reader we can access the content of the canvas through the following outputs. Plain text output. This output describes the visual content present on the canvas in plain text. Table output. The table output lays out the content of the canvas in the form of a table based on the spatial location of each element. Sound output. This mode explains the movement of the objects present in the canvas. Top to bottom movement is represented by a decrease in frequency and left to right through panning. How to select an output. In the P5.js web editor there are two ways to select the accessible outputs that we want to make available. When we press the Play Sketch button accessible to screen readers, the plain text output will automatically be available. If we want to access other outputs we should do the following. First, stop the sketch by pressing the Stop Sketch button and go to Settings. Within Settings we must find the Accessibility tab. In the Accessibility tab and under the Accessible Text-Based Canvas section we can choose our preferred outputs. Within Settings and under the Accessibility tab it is also possible to activate a lint warning sound that should make debugging easier. In Settings and under the General Settings tab we can increase the size of the font and select a high contrast theme. After choosing our settings we can close the Settings window and go back to coding and playing our sketch. It is possible to add these accessible outputs to P5 sketches outside of the P5.js web editor by including the P5.accessibility.js library. You can learn more about the library here. Keyboard shortcuts. There are also ways to turn on the accessible outputs using keyboard shortcuts. Once we are on the code editor area, we can use the following shortcuts. We have listed the shortcuts for Windows computers. If you are using Mac OS, please use the Command key instead of Control. Shift plus Control plus 1 turns on all the accessible output options, including audio. Shift plus Control plus 2 turns off all the accessible output options. Control plus Enter, this is used to run a sketch. If you already have accessibility options turned on, they will show up as well. Shift plus Control plus Enter, this is used to stop a sketch. The full list of shortcuts is also available in the P5 web editor, under Keyboard Shortcuts in the Help and Feedback section of the menu. Lessons. Lesson 1, Hello World. In this section we go through some basic functions in P5 and look at how the screen reader will read the output. There are two main functions we will use in our programs. The setup function runs once, and is typically used for initialization, or for creating a program that does not need a loop running code repeatedly. The draw function runs over and over again, and is used to perform a certain action repeatedly and for animation. Now we can open the editor, alpha.p5js.org, and look for the code edit area. If you notice, there's some code there already. Whenever you open the editor, by default it will create a setup function and a draw function. However, for our first Hello World program, we will take a step back and delete everything. Once we have a blank editor, we create a setup block and add one line. Function setup, create canvas, 200,200. The create canvas function creates a canvas for us to draw or display the output. The canvas is the space on which the output is drawn or displayed. The code above creates a canvas of width and height 200 pixels. Since there is no movement, we will take a look only at the text and table outputs. Text output for Lesson 1. Your output is a 200 by 200 white canvas containing the following 0 object. Table output for Lesson 1. White canvas is 200 by 200 of area 40,000, contains 0 objects. As expected, the outputs do not have any details apart from that of the canvas. Now, let's move on to the next lesson where we add some basic shapes. Lesson 2, Basic Shapes. In this example, we will draw an ellipse on the top left, and a rectangle on the bottom right of the canvas of size 500 by 500 pixels. First, let's create the canvas and draw a shape in the setup function. Feel free to copy the code to the editor and run it. Function setup, create canvas, 500, 500, ellipse, 50, 50, 20, 20. This code creates a canvas of 500 by 500 pixels and then draws an ellipse. The first two numbers we pass to the ellipse indicate where the center of the ellipse will be on the canvas. In this case, that is 50 and 50 pixels. The next two numbers indicate the width and height of the ellipse. In this case, they are both 20 pixels, implying we want to draw a circle. It is important to note that the top left corner of the canvas is 0.00 pixels and the bottom right corner of the canvas is 0.500,500 pixels. Now, we can also type this code a bit differently. We can create the canvas in the setup function and draw the shape in the draw function. Function setup, create canvas, 500, 500, function draw, ellipse, 50, 50, 20, 20. In the previous case, the ellipse is drawn once in setup and never again. But, in this case, the ellipse is drawn again and again in the canvas. Since the numbers passed to the ellipse are the same each time, it doesn't make a difference. However, if we wanted to change its position each time and make it move, then we would have to do it in draw. Note, remember, that everything in the canvas is drawn one over the other. In this case, the output will be following. Text output for Lesson 2. The overview for the text output contains, your output is a 500 by 500 white canvas containing the following one object. This description is followed by a list of elements where the shape, color, position, and area of each element are described, in this case, white ellipse at top left covering 0.13% of the canvas. Each element can be selected to get more details. A table of elements is also provided. In this table, shape, color, location, coordinates, and area are described. Example, white ellipse location equals top left coordinates equals 50x, 50y area equals 0.13%. Table output for Lesson 2. The overview for the table output contains, white canvas is 500 by 500 of area 250,000 contains one objects, one ellipse. This is followed by a table that describes the content spatially. It is a 10 by 10 table structure where each element is placed on a cell of the table depending on its position. Within each cell and element the color and type of shape of that element are available, example, white ellipse. These descriptions can be selected individually to get more details. A list of elements where shape, color, location, coordinates and area are described, example, white ellipse location equals top left coordinates equals 50x, 50y area equals 0.13%, is also available. You can try the basic shapes example on the P5 editor. Lesson 3, Color. In these examples, we look at different ways to add color to our sketch. First, let's look at background. We can use this function to add a background color to the canvas. Copy the below code to try it out. Function setup, create canvas, 500, background, 255, 0. Here, we have given the color in RGB format. In this format we can describe colors by saying how much red, green and blue the color has. RGB values must be integers between 0 and 255, with 0 being no color, and 255 highest amount of a certain color. The outputs will now contain red, 255, 0, canvas. Now we can give color to our shapes using the function, fill. Copy the below code to try it out. Function setup, create canvas, 500, background, 255, 0, function draw, fill, 258, ellipse, 50, 20, fill, 20, 258, ellipse, 250, 20, fill, 20,150,250, ellipse, 450, 20. Now, in the plain text and grid output, we will notice that each shape is prepended with the color of the shape. Text output for lesson 3. In the text output the overview is as follows. Your output is a 500 by 500 red, 255, 0, canvas containing the following 3 objects. After this we see the list of objects, with their color name and the RGB value. For example, crimson, 258, ellipse at top left covering 0.13% of the canvas. Each object contains a link that when selected provides more details. Grid output for lesson 3. The overview is as follows. Red, 255, 0, canvas is 500 by 500 of area 250,000 contains 3 objects, 3 ellipse. And in the table, we will find the objects in the grids corresponding to their location. Crimson, 258, ellipse, and green, 258, ellipse. You can try the color example on the P5 editor. Instead of using red, green and blue values, we can also pass just one value from 0 to 255. This is known as grayscale. It means that red, green and blue will take the same value and the result will be between black and white. 0 being black, and 255 white. Lesson 4, Text. With P5, it is also possible to draw text on the canvas. We can add text to the canvas using the text function. This function requires us input 3 values inside the parentheses, the text we want to display written between quotation marks, followed by the X and Y position in pixels to display the text in the canvas. Copy and try out the below code. Function setup, create canvas, 500, background, 200, function draw, fill, 255, 0, text, hello world, 50. Note that fill also affects text, and that the text we want to write has to be written between quotation marks. Now, let's go through the output to see what it says. Text output for lesson 4. The overview is as follows. Your output is a 500 by 500 gray, 200,200,200, canvas containing the following 1 object. Then there is a list of the objects. For example, hello world. Red, 255, 0, at top left of the canvas. Grid output for lesson 4. The overview is as follows. Gray, 200,200,200, canvas is 500 by 500 of area 250,000 contains 1 object, 1 text. And in the table you will see the actual text and its color in the appropriate location, example, hello world. Red, 255, 0. You can try the text example on the P5 editor. Exercise, bar graph. Now that we have covered how to draw basic shapes and write text on the canvas, let's look at how we can create a bar chart with them. Using rectangles and some numbers, we can create bar graphs. Since we expect the entire sketch to be static, we can do the whole thing in the setup function. Let's start with a sample dataset that we want to depict. Animals in the park. Dogs, 260. Cats, 300. Hamsters minus 100. Rabbits, 50. Spiders, 10. First we create a canvas. Function setup, create canvas, 500,500. Now we can add some rectangles that represent each animal type. Notice that we will be adding comments in our code. Comments are lines in our code that are not executed and can be notes to ourselves. They start with // in the beginning of the line. We will create 5 rectangles, one for each animal type. Remember that when we draw a rectangle, the first 2 values indicate the top left of the rectangle. If we want our bar graph to start on the left of our canvas, we need to calculate the numbers based on that. If we decide to make each bar with 50 pixels height, and to make the width represent the number of animals, for our first rectangle that represents the number of dogs, the width would be 260 because there are 260 dogs. Then the values for this rectangle would be 0, 0, 260, 50. Function setup, create canvas, 500, 500, // we will use the fill function to add color to the first bar of our chart. Fill, 255, 0, 0, // in this case our color is 255 red, 0 green, 0 blue. Rect, 0, 0, 260, 50. Now let's add the corresponding text. Function setup, create canvas, 500, 500, fill, 255, 0, 0, rect, 0, 0, 260, 50, text, dogs, 260, 0, 75, // remember that the function text requires the text and the x and y values for its position. And voila! We just added the first bar on our graph chart. Text output for bar graph 1. Your output is a 500 by 500 white canvas containing the following 2 objects. Red, 255, 0, 0, rect at top left covering 5.2% of the canvas. Dogs, 260, red, 255, 0, 0, at top left. Now let's add rectangles to represent 300 cats, 100 hamsters, 50 rabbits, and 10 spiders. Remember that the values for the function rect, in our case should be, rect, 0, y position, number of animals, 50. Function setup, create canvas, 500, 500, fill, 255, 0, 0, rect, 0, 0, 260, 50, text, dogs, 260, 0, 75, rect, 0, 100, 300, 50, // here the second value, y position, is 100 so that we can draw the second bar under the first bar. Text, cats, 300, 0, 175, rect, 0, 200, 100, 50, text, hamsters, 100, 0, 275, rect, 0, 300, 50, 50, text, rabbits, 50, 0, 375, rect, 0, 400, 10, 50, text, spiders, 10, 0, 475. The text output would be text output for bar graph 2. Your output is a 500 by 500 white canvas containing the following 10 objects. Red, 255, 0, 0, rect at top left covering 5.2% of the canvas. Dogs, 260, red, 255, 0, 0, at top left. Red, 255, 0, 0, rect at top left covering 6% of the canvas. Cats, 300, red, 255, 0, 0, at top left. Red, 255, 0, 0, rect at top left covering 2% of the canvas. Hamsters, 100, red, 255, 0, 0, at top left. Red, 255, 0, 0, rect at top left covering 1% of the canvas. Rabbits, 50, red, 255, 0, 0, at top left. Red, 255, 0, 0, rect at top left covering 0.2% of the canvas. Spiders, 10, red, 255, 0, 0, at top left. Now we can add different colors to each bar. Function setup, create canvas, 500, 500, fill, 255, 0, 0, rect, 0, 0, 260, 50, text, dogs, 260, 0, 75, fill, 0, 255, 0, rect, 0, 100, 350, text, cats, 300, 0, 175, fill, 0, 0, 255, rect, 0, 200, 150, text, hamsters, 100, 0, 275, fill, 200, 100, 0, rect, 0, 300, 50, 50, text, rabbits, 50, 0, 375, fill, 0, 200, 200, rect, 0, 400, 10, 50, text, spiders, 10, 0, 475. Our bar graph is ready. Here is the output. Text output for bar graph 3. Your output is a 500 by 500 white canvas containing the following 10 objects. Red, 255, 0, 0, rect at top left covering 5.2% of the canvas. Dogs, 260, red, 255, 0, 0, at top left. Green, 0, 255, 0, rect at top left covering 6% of the canvas. Cats, 300, green, 0, 255, 0, at top left. Blue, 0, 0, 255, rect at top left covering 2% of the canvas. Hamsters, 100, blue, 0, 0, 255, at top left. Orange, 200, 100, 0, rect at top left covering 1% of the canvas. Rabbits, 50, orange, 200, 100, 0, at top left. Cyan, 0, 200, 200, rect at top left covering 0.2% of the canvas. Spiders, 10, cyan, 0, 200, 200, at top left. Now that we created a graph together, you should be able to do it by yourself and share the results with your friends. Forum, GitHub, Twitter, Instagram, Discord. P5.js is currently led by Chanchan Yi and was created by Lauren Lee McCarthy. P5.js is developed by a community of collaborators, with support from the Processing Foundation and NYU ITP. Identity and graphic design by Jarrell Johnson. Copyright info. Processing. P5.js. Processing.py. Processing for Android. Processing for Pi. Processing Foundation. Skip to main content. When you write P5, you are doing what is called client-side programming. The JavaScript code we write is executed by the browser itself and runs on the user's local computer. For controlling the local behavior of a web page, this is enough. However, there are lots of tasks that web applications perform that can only be accomplished with server-side programming. Here are some examples of functionality that would require server-side programming. Storing data over time. How many times have users visited this page? What are the high scores of this game? Etc. User login/authentication. Accessing APIs. Connecting to hardware, such as Arduino or Kinect. This is a unique sort of scenario where we may run a server-side program locally on a client machine to transfer data from a hardware device that the browser does not have access to. Before we start writing our own servers, we should note that we have been running server-side programs all along. Every time we type Python m simple HTTP server, or Python m http.server if using Python 3, we are running a simple server program written in Python. What does this server program do? It takes requests, could I please have that index.html file, and responds to those requests, here, enjoy this index.html file. This is all this simple HTTP server can do, handle HTTP requests and serve up files. We don't need Python for this. We can write server-side programs in all sorts of languages, PHP, Ruby, Java, the list goes on, including JavaScript. For example, here's a simple HTTP server written in JS. Let handle request equals function, request, response, response.writeHead, 200, content type, text/plain, response.end, hello world \n, const http equals require, http, let server equals http.createServer, handle request, server.listen, 8080. This server is even more simple than the Python one. It doesn't even serve any files. No matter what the request might be, the only response ever is, hello world. This server is written in JavaScript using Node.js, a platform for building JavaScript network applications. We'll be getting to the specifics of how this example works later. Hello World Node. The first thing we need to do to get up and running with server-side programming in JavaScript is to install Node. Once you've installed Node, to make sure it's working, just open up Terminal and type Node. If it's installed, you'll see a prompt. You can type any JavaScript here just like in the browser console to test, hit Ctrl+C twice to exit. Now make any old file with JavaScript code in it. For example, make a file called hello.js with console.log, hello. Now back in terminal type node hello.js. You should see hello. Back in the console. Congratulations, you are now executing server-side JS code via the command line. Hello World HTTP server. The next step we need to do is to write a server program that handles HTTP requests. An HTTP request is that thing that happens when you type something into the address bar of your web browser. http://www.google.com makes a request to Google's server, which then sends you a response, filled with the HTML found in Google's homepage. To write a Node server that handles requests, we write a function that receives a request argument and acts on a response argument. Let handle request equals function, request, response, // handle the request with a response. Now we pass that function as a callback to a create server method and listen on a port number. Let server equals http.createServer, handle request, server.listen, 8080. We are missing one line of code, however. Where does HTTP come from? We need to import the Node HTTP module. Const HTTP equals require, HTTP, Node comes with a few built-in modules, and there are 70,000 and counting more you can install via npm. Let's put all the code from above together and add one more line. We'll send back the text, hello world, for every HTTP request made to the server. // this function handles an incoming request // and sends back out a response. Let handle request equals function, request, response, response.writeHead, 200, content type, text/plain, response.end, hello world \n, // HTTP module. Let HTTP equals require, HTTP, // create a server with the handle request callback. Let server equals http.createServer, handle request, // listen on port 8080. Let IO equals require, socket.io, server, console.log, server started on port 8080. If we save this as server.js, we can then execute the server via node server.js. Navigate to your browser and type localhost 8080 into the address bar and you should see, hello world. Serving a P5 sketch. We certainly aren't the first to build a server application with Node. And because just about all servers need a lot of the same code, many developers will use an abstraction on top of Node such as Express, a web application framework for Node. The Getting Started with Express guide will give you a good basic sense of how such a framework works. For us, we're going to bypass Express and do a couple more basic things with Node as it relates to P5. For example, how would we serve a P5 sketch? The first thing we need to learn is how to use the file system module to read in a file, say index.html, and write the contents out as a response to a request. // the file system module const fs equals require, fs, function handle request, request, response, user file system module to read index.html file fs.read file __ dirname plus / index.html / callback function for reading function data / if there is an error if response.writeHead 500 return response.end error loading index.html / otherwise send the data, the contents of the file response.writeHead 200 response.end data. We're really living in JavaScript land now. The read file function takes two arguments. The first argument is the path of the file we want to read, and the second is a function that will be triggered once the file has been read. Note how we are passing in an anonymous function as an argument to the read file function. While this server works, it will still only send back index.html no matter what the user actually requests. What if you are serving multiple pages including HTML, JS, and CSS files? In this case, we'll want to read in the actual request from the user via request.url. We can then serve the file back up with est URL, we can then serve the file backup with the appropriate type, looking at its file extension. Const http equals require, http, const path equals require, path, const fs equals require, fs, function handle request, req, res, // what did we request? Let path name equals req URL, // if blank let's ask for index.html if path name equals / path name equals /index.html // okay what's our file extension let ext equals path.xname, path name, / map extension to file type const type ext equals .html, text /html, .js, text /javascript, .css, text /css, // what is it? Default to plain text let content type equals type ext, text /plain, / now read and write back the file with the appropriate content type fs.read file, _ dirname plus pathname, function, data, if, res.writehead, 500, return res.end, error loading plus pathname, / dynamically setting content type res.writehead, 200, content type, res.end, data. This handle request method will serve a P5 sketch including an index.html, sketch.js, and style.css. You can see the full example here. Sockets. If we want a client to have a synchronous connection with other clients, for example, in a chat application, we can use WebSockets. With P5, for example, we could send the mouse location from one sketch to another to create a multi-user whiteboard application. To accomplish this, we'll need to install the socket.io module. $npm install socket.io. Now in our server program, we can listen for socket connections. Let server equals http.createServer, handle request, server.listen, 8080, let io equals require, socket.io.listen, server. The io object can be passed callback functions to handle events. For example, when a new connection is made, we could pass in a function that prints out a notice to the console. / register a callback function to run when we have an individual connection / this is run for each individual user that connects io.on, connection, function, socket, console.log, we have a new client, plus socket.id. The anonymous callback function receives a socket argument. This socket argument is a reference for the current client connected. That client can also be passed callback functions. For example, here is a callback for when a client disconnects. / we are given a WebSocket object in our function, socket, console.log, we have a new client, plus socket.id, socket.on, disconnect, function, console.log, client has disconnected. We can also create custom callbacks for certain kinds of events. Let's make up an event called mouse. Our P5 sketch will send mousex and mousey for each mouse event. The server can handle that event by sending back that data to any other connected clients. Socket.on, mouse, function, data, / data comes in as whatever was sent, including objects console.log, received, mouse plus data.x plus data.y, / send it to all other clients socket.broadcast.emit, mouse, data. Now we have a socket server that receives mouse coordinates and passes them back to all other connected clients. Note that the server does not broadcast the data back to the sender itself, that can be accomplished with io.sockets.emit, mouse, data, . All we have left to do is broadcast and receive the mouse values from our P5 sketch itself. Remember this is the part that is executed by the client browser itself and is not part of the server program. First, we have to include socket.io in index.html. Insert this line before the line that includes the sketch file. Script language equals JavaScript, type equals text /JavaScript, src equals /socket.io /socket.io.js /script. Then, we can use socket.io in setup, like this. Let socket equals io, function setup. Once we have our socket, we can broadcast mousex and mousey. Let's do it whenever the user drags the mouse. Function mouse dragged, / make a little object with mousex and mousey let data equals x, mousex, y, mousey, / send that object to the socket.emit, mouse, data. Oh, and we forgot one more thing. We need to do something with the data when we receive it. Here we'll create an anonymous function that will handle our mouse event. Function setup, // we make a named event called mouse and write an / anonymous callback function socket.on mouse function data / draw a blue circle fill 0 0 255 no stroke ellipse data.x data.y 80 80. See the full example for all the pieces working together. Tom Igo also has a great tutorial for using a web socket to send data from an Arduino. Deploying your app. This wiki only covers how to set up and run simple node servers locally. When you want to release your app into the wild, you'll need an actual server to run your app on. Node.js running on Heroku. Node.js and Amazon Web Services. From Sean's live web course, Sam Slover's notes on Node.js and Amazon EC2. Adapted from tutorial written by Dan Schiffman for ITP Creative.js. https://p5js.org. If you would like to edit this wiki and don't already have edit access, please open an issue or comment on an existing one noting the wiki page you'd like to edit. You will then be added as a repository contributor with edit access.